deriving the equilibrium equation for the unconfined as well as for the confined aquifer, we need or we have to take the base of certain laws. See, if you remember that in geotechnical engineering also we have a Darcy's law, which is dealt with the groundwater philosophy or groundwater analysis. So let's start and let's see what is the well hydraulics according to the Darcy's law. The percolation of water through soil was firstly studied by this Darcy in 1856, who gives us or who tells us, demonstrated us that experimentally, but he gives us a experimental or he gives us a final output by doing the experiment that for laminar flow condition in saturated soil, the rate of flow or the discharge per unit time is proportional to the hydraulic gradient. So it gives us or he gives us one equation, one expression, that is the rate of flow when there is the laminar flow is there in the saturated soil, then the rate of flow, the discharge per unit time, it is proportional to the hydraulic gradient. He gives us one equation, that is discharge is equal to K into I into the area, where I is the hydraulic gradient, K is the coefficient of permeability, A is the cross-sectional area of a soil which is perpendicular to the direction of the flow, and if we know that if we want to find out the velocity, then we have to take the ratio of a discharge and area, means that discharge it is also equal to the area into velocity. So if you want to find out the velocity, we can substitute the value here and we can rearrange this term. Okay, so either this equation will give you the discharge or this equation will give you the velocity of the flow. So according to the Darcy's law, see, this Darcy's law is valid only for the laminar flow. This is the limitation. See, according to him, this Darcy's law represents the statistical microscopic equivalent of Navier-Stokes equation of motion for viscous flow of a groundwater. And this is valid only for the laminar flow, because a very small pore dimension is available in the fine grained soil. In this, only a laminar flow should exist. But in coarse grained soil, we know that we have if gravel and sand is there, then in such type of a soil, the turbulent flow may be expected under certain conditions, because there is a large space or there is a distance between these two particles is high. So in this type, the turbulent flow might be occur under certain or under some conditions. So it has been borne out by experiments by if one of the experiment he had done, that the limits of validity of Darcy's law may be restricted or maybe depends upon the with respect to the particle size, velocity of flow, and the hydraulic gradient. So the Fancher, Lewis, and Barnes, these are the three scientists who also demonstrated that the flow through the sands remains laminar and Darcy's law valid so long as Reynolds number expressed in the form below is equal to or less than unity. So it is also depends upon the Reynolds number or the other factors, that is the density, then that is the your velocity, particle size, etc. So again, for the groundwater flow occurring in nature, the law is generally having some limitation. Uh, in rock aquifers, then in unconsolidated aquifers with steep gradients, or in those containing large diameter solution openings. Also, in the vicinity of wells having a steep gradient, the Darcy's law may not be applicable. So, by analyzing this limitation or by studying this limitation, we get the knowledge or we concluded that this law is limited and obstructed up to a level or up to the point that this is validation of this law is up to the laminar flow only. So based on this, again, one of or two of the scientists had again done the analysis uh, based on the steady state flow in a well. So according to them, what exactly the parameters that we had searched out or we had got that we are going to study in this steady state flow in a well. So the previous equation, that equation is definitely helps us to finding out the discharge through the well or finding out the yield from the well. We have to take the base of this Darcy's law equation as well as we have to set another level and another platform to derive the equations furthermore. So let's see. One of the law is the Darcy's law, and secondly, we have to follow the Duipits theory. Duipits, as well as it is also called as the themes theory. Duipits, it gives us this analysis in nearby 1863, and this analysis then modified by themes in 1906. So hence, this theory is also known as a Duipits as well as a themes theory. So let's see. See, when when we want to penetrate a well in excessive homogeneous aquifer, then the water table initially remain horizontal in the well. If the well is penetrated, the well is excavated, okay, or it is there under the ground. Then the initial water level is at the horizontal level. Then as soon as we are starting to extract this water from the well, what happens? Water is removed from the aquifer, definitely, but the water table and this piezometric surface, this horizontal surface, is lowered depending upon the type of aquifer. If this is an unconfined aquifer, it gives us a depression cone, as well as if it is a confined aquifer, because of this confining area, the water level it reduces and it lowered below the water table or below the confining layer. So depending upon the type of aquifer, this water table is lowered, resulting in a circular depression in a water table or the piezometric surface level. This depression is called as a cone of a depression. According to Duipits, see, he had done the research, he had done the analysis. He That's why he gave us this parameter, or he gave us this technical terms. That is, when once the water is pumped out through the aquifer, the level of the water table is lower, and it gives us a cone of a depression, which is in a circular depression size or a circular reduction uh, shape. So hence this depression is called as a cone upper depression, or it is also called as a drawdown curve. So next, at any point away from a well, the drawdown is the vertical distance by which the water table or the piezometric surface is lowered. See, once the water is extracted, so the away from the well, if certain after this See, the level is the cone of depression is not available at the level of the water table. It gives us some depression. It gives us the circular depression, which might be meet at the point, and this point is coincide with the initial water level. So hence here this point reflects that at any point away from the well, the drawdown is the vertical distance by which the water table or the piezometric surface is lowered. The analysis of such a radial flow towards a well was originally proposed by Duipits in 1863 and later modified by Thiem in 1906. For this sake of analysis, we have to take two cases, that is well in unconfined aquifer and well in fully penetrating in confined aquifer.